Okay, going to be looking at another benzene mechanism now. It's the chlorination of benzene, the reaction of chlorine and benzene. It's an electrophilic substitution mechanism, just like the nitration mechanisms. A lot of similarities, you'll be pleased to know. But the first thing we need to look at is the overall reaction. So because it's substitution, something's going to come off the benzene molecule and be replaced by something from here. So if you remember from your notes, the products are chlorobenzene and HCl. Now that won't happen without some help, and the help comes from the catalyst, and you can either use AlCl3 or FeCl3. Now if that was bromine, Br2, you'd just get Br there, and the catalyst would be AlBr3 or FeBr3. So that's nice and straightforward there. So I'm just going to do this mechanism because it's identical to the bromine one. So the first step is the formation of the electrophile. This is where the catalyst starts its job. So if we look at these two substances here, there's your first product. So effectively one of the chlorines, not quite the chlorine, as you'll see when we get down to this bit here, one of the chlorines goes onto there, becomes negative, so the other product, Cl+, hide that, and that's our electrophile, and that's going to be accepting a pair of electrons. The metal halides, as you can see there, are classed as halogen carriers. Okay, they're reformed at the end, so they're known as catalysts. So just a quick discussion about, well, why can aluminium chloride or FeCl3, why can they do that? If I do a quick dot and cross diagram, so there's the covalent bond between these two chlorine atoms, so we'll do the dots on the left and we'll do the crosses on the right. Okay, now if you notice, the aluminium only has 2, 4, 6 electrons in this shell here, so effectively it can take another pair of electrons. So it does that and it uses these, but what that does is it actually breaks this bond here. Okay, so that's heterolytic fission, remember from your alkene chemistry. Both of the electrons in the bond are going on to this left hand chlorine, so this chlorine on the right gets none of the electrons from the bond, so heterolytic fission. Now if you think about it, chlorine's got 7 electrons in its outer shell anyway. It's actually going to keep this one here, so this has got an extra electron, so effectively this is Cl minus. So if you add Cl minus onto AlCl3, which is neutral, you're going to get AlCl4 minus. The Cl on the right started with 7 electrons, but now it's only got 1, 2, 3, 4, 5, 6, so that's lost an electron, so that's effectively Cl plus now, and there it is there. Okay, so that's how the AlCl3 does its job. Okay, so we'll just flick on to the next slide. Right, so the next part of the mechanism is the electrophilic attack by the what should that say? That should say Cl+. Sorry about that. Silly me. Right. Oh, right, should I quit this or what? Let's keep going, shall we? For comedy effect. Right, so we've got the electrophile, the correct electrophile. What's going to happen? Just like before, a pair of electrons is going to be attracted to this Cl+ electrophile, and that's going to create those lovely looking intermediates. Okay, and I'm going to scrap this now. Sorry, this is just not good enough. You deserve better than this. Sorry, I'm really sorry.